Resilience is not a personality trait. It is structural engineering. In this model, the human being is treated as a complex, adaptive system. If the environment is volatile, nonlinear, and unpredictable, then survival requires architecture, not motivation. This is the structural redesign required for survival in a nonlinear environment. You are legacy biological hardware operating in an accelerating digital ecosystem. The environment is volatile. The goal is stability and purpose. The risk is entropy. Without structural intervention, disorder wins. Before adaptation, the system must stand. We begin by increasing load-bearing capacity, buffers, redundancy, and strategic risk stratification. No movement without foundation. Buffers decouple inflows from outflows. Financial reserves, skill reserves, health reserves. They absorb volatility before it reaches your structural limits. Without buffers, every shock becomes existential. Eliminate single points of failure. Do not rely on one income stream, one identity, one skill set. Redundancy ensures that when one node fails, the system continues functioning. Avoid the fragile middle. Extreme safety on one side, controlled high convexity on the other. Protect the core. Experiment at the edges. This is how you survive fat tail events and benefit from volatility. Static systems crack over time. To survive, the architecture must regulate itself. We now install feedback loops, counter-cyclical accumulation, and internal margin. All feedback must meet 4 conditions: stability, accuracy, settling time control, overshoot avoidance. Without proper calibration, overcorrection creates oscillation. Resilience requires controlled response, not emotional reaction. Fragility builds during calm periods. When everything looks stable, leverage rises, risk perception falls. Resilient systems accumulate reserves during expansion, so they survive contraction. Control slack equals survival capacity. You must preserve degrees of freedom, time margin, financial margin, cognitive margin. Without maneuverability, the system becomes trapped in maladaptive loops. Resilience is not returning to baseline. It is the ability to stretch beyond design boundaries without catastrophic failure. We now engineer extensibility. Brittle systems function perfectly until they collapse. Extensible systems bend, absorb energy, and reconfigure. The goal is not rigidity. The goal is controlled elasticity. Do not maximize one variable. Optimize across 3 axes: wealth, autonomy, meaning. Good enough across all axes is structurally superior to extreme optimization on one. Over-optimization creates fragility. Resilience is engineered. It is not inherited. It is constructed. When buffers exist, feedback is calibrated, risk is stratified, and margin is preserved. System status, nominal. The retrofit is complete. If you want to explore more ideas about thinking, money, and modern life, you can subscribe to the channel.